Okay, so first, the homework that we did not get to on page 518. Question number 1 says, a straight wire, 0.5 meters long, is moving straight up through a 0.4 Tesla magnetic field pointed in the horizontal direction at a speed of 20 meters per second. So we have a speed of 20 meters per second. We have a length of 0.5 meters. And we have a magnetic field strength of 0.4 Teslas. And it's moving straight through a 0.4 Tesla magnetic field pointing horizontally at a speed of 20 meters per second. Okay, so perpendicular. What is the EMF induced? So EMF is equal to BLV sine theta. Sine theta is going to be 90. So EMF is equal to 0.4 Teslas times 0.5 of a meter times 20 meters per second. So half of 20 meters per second is 10. 10 times 0.4 should be 4 volts. Number 2. Oh, sorry. There's a part B. The wire is part of a circuit of total resistance of 6 ohms. What is the current? So V equals IR. So I equals V over R. So that's my V, 4 volts. My resistance is 6 ohms. So my I is 2/3 of an amp, or 0.6 repeating, but that would just be not messy. Number 2, a straight wire, 25 meters long, is mounted on an airplane flying at 125 meters per second. So V is 125 meters per second. The wire moves perpendicularly through the Earth's magnetic field, and in this question they want you to use it as 5 times 10 to the negative 5, okay, because they give it to you here. So use it as 5 times 10 to the negative 5 Teslas. What is the EMF? So EMF is equal to BLV sine theta, and again the theta is going to be 90. So 5 times 10 to the negative 5 Teslas, 25 meters, and 125 meters per second. EMF equals, I don't know that I can do that, am I yet? 125 times 125. 5e to the 5 negative times 25 times 125. Is it 0.15625? 0.15625 volts. No part B. Number 3 says a permanent horseshoe magnet, so that's this dude, like the one you were taking the thing off of. Okay, so a permanent horseshoe magnet is mounted so the magnetic field lines are vertical. Of course, you should probably read the rest of the question before you draw the thing. So it means that it's standing up like this, right? So that the field lines are going up and down. So it's mounted so that the magnetic field lines are vertical. If a student passes a straight wire between the poles and pulls it towards herself, the current flows in the wire from left to right. I'm not sure if I can draw this 3D. Okay, so here's the student. The wire needs to be maybe a different color. Okay, so the wire's like this. And the field lines, of course, are going to be here. Okay. And so she's going to pull it towards herself. She's going to pull it out this way. Left to right. Left would be on this side, right? If I'm standing looking at this magnet, right would be on the inside. So it says the student passes a straight wire between the poles and pulls it towards herself. The current through the wire is from right to left. Right to left would be this way. Right, because this is my right hand moving to my left. Your book always assumes conventional. So if I'm pulling the wire towards myself, and the current is coming out of the palm of my hand, right? So the force needs to be pointing from right to left, and the wire needs to be coming towards me, which means my fingers need to be pointing up. And so the question says, which is the north pole of the magnet? It has to be down here, because my fingers have to be pointing up, and the field lines always go from north to south. Okay? All right, number 4 says a straight wire, 30 meters long, moves 2 meters per second, perpendicular, so that means your sine theta is going to be 1, through a 1 Tesla magnetic field. What is the EMF induced? So EMF is equal to BLV sine theta. EMF is equal to 1 times 30 times 2. Definitely higher order math. And hopefully you get something like 60 volts. And then it says the total resistance of the circuit is 15 ohms. What is the current? V equals IR. I equals V over R. So 60 volts over 15 ohms. I should be about 4 amps. Okay, so that's the homework from page 518 that we didn't go over in class.